कैपेसिटिव। देखते हैं इसका क्या आंसर होगा। सो एट फ्रीक्वेंसी लेस देन रेजोनेंट फ्रीक्वेंसी, सो फ्रीक्वेंसी तो आपने क्वेश्चन में दे दी है लेस देन, तो देखते हैं क्या ऑप्शन होगा। व्हेन एफ इज लेस देन एफ नॉट, और बात जो की गई है दोनों सर्किट के बारे में की गई है, सीरीज और रेजोनेंस। तो देखते हैं, अगर हम सीरीज की बात करें तो देखिएगा सीरीज, इधर होगा हमारा पैरेलल, ठीक है यहां तक। तो अगर हम सीरीज की बात करें, सो XL is proportional to omega and XC is proportional to 1 upon omega, ठीक है। सो फ्रीक्वेंसी लेस देन द रेजोनेंट फ्रीक्वेंसी है, तो अगर ये कम है तो ये भी कम होगा, और ये कम है तो ये ज्यादा होगा, ठीक है। सो इन सीरीज सर्किट XC is greater than XL, so it is capacitive, it is कैपेसिटिव, ठीक है यहां तक। अगर हम पैरेलल की बात करें तो देखिए पैरेलल में क्या होगा, BL is 1 by XL, that is what 1 upon omega L, ठीक है। सो VL जो है वो किसके प्रोपोर्शनल होगा, 1 upon omega के। ये कम है तो ये ज्यादा होगा, ठीक है यहाँ तक ना। जो कैपेसिटिव ससेप्टेंस है वो होता है 1 upon XC, that is cos 1 upon omega C, so VC is directly proportional to frequency, so it is low, then it is also low. So in parallel circuit we have VL greater than VC, so your circuit is inductive, ठीक है यहां तक। सो देख लीजिए सीरीज के लिए कैपेसिटिव होगा और पैरेलल के लिए क्या होगा, इंडक्टिव। जस्ट चेक फर्स्ट, हमारे जो सी और डी ऑप्शन है वो तो दोनों ही गलत हो गए हैं, क्योंकि ऐसा तो हो ही नहीं सकता है, वो था रॉन्ग ना। चेक आइदर ए और बी, सीरीज सर्किट कैपेसिटिव यस, पैरेलल सर्किट इंडक्टिव, सो योर ऑप्शन नंबर ए इज करेक्ट। देखते हैं नेक्स्ट क्वेश्चन अपना क्या है। सो होपफुली ये क्वेश्चन समझ में आ गया होगा आप लोगों को। अब बढ़ते हैं आगे, और डिस्कस भी मैं कई बार कर चुका हूं ऐसे क्वेश्चन को, ठीक है। Now next question for your resonance circuit is, so नेक्स्ट क्वेश्चन जो है हमारा, नेक्स्ट क्वेश्चन जो हमारा है, इन एन RLC सीरीज सर्किट, इन एन RLC सीरीज सर्किट, in an RLC series circuit during resonance, the impedance will be, ठीक है। यहां तक देखते हैं अपना पहला ऑप्शन क्या है। पहला जो ऑप्शन है वो है 0, अगला जो ऑप्शन है वो है मिनिमम, और सी ऑप्शन जो है हमारा है, जैसे सी ऑप्शन है मैक्सिमम, और लास्ट ऑप्शन जो है हमारा है नन ऑफ दिस, ठीक है यहां तक। सो देखते हैं क्या होगा। इन एन RLC सीरीज सर्किट ड्यूरिंग रेजोनेंस द इम्पीडेंसेस, नाउ if you again have the series circuit and your impedance is this, and at series resonance XL is equals to XC, so your Z is equals to R at the minimum. That's why it is called acceptor circuit. So your series impedance should be minimum. But for parallel circuit, it is for series circuit, and this is one for parallel circuit. Okay, parallel circuit. ठीक है यहाँ तक. So for this circuit your option number B is correct. देखते हैं अपना next question क्या है. So let's start the next question. So लिखते हैं next numerical अपना on resonance. So हमारा क्वेश्चन है a series RLC circuit, a series RLC circuit a series RLC circuit when excited by a 10 volt sinusoidal voltage source of variable frequency exhibit resonance at 100 hertz and has a 3 dB bandwidth of 5 hertz. The voltage across the inductor, L at resonance is option है आपके 10 वोल्ट. अगला जो ऑप्शन है 10√2 और सी ऑप्शन जो है 10/√2 और जो लास्ट ऑप्शन है वो है 200 वोल्ट. ठीक है, देखते हैं क्या होगा इसका आंसर. ना a series RLC circuit excited by a 10 volt. Okay, the input is here. The given question, your input B in is 10 volt. Okay, of variable frequency exhibit resonance at 100 hertz. That means this meaning resonance at 100. The F0 is 100. Okay, then 3 dB bandwidth. That is delta F0 is given to you. That is 5 hertz. Okay, then what is the voltage across the inductor? Okay, now first thing, if you remember their quality factor. A quality factor is what? VL upon V in. Okay, it is VL upon V in. So VL equals to, I can write quality factor times V in. So to have the voltage across the voltage across the inductor, we need quality factor. Okay, so quality factor is what? Quality factor is, if you remember, omega naught L by R, and omega is this and R by L. So it is what? Omega naught upon bandwidth, but it is in terms of radian per second. Now for hertz it is F0 upon delta F. So F0 is given to, I think F0 is how much? 100. And how much is delta F? That is bandwidth 5. So it is 20. Okay, now we have calculated the 20, that is quality factor. So your VL is 20 into V is how much? 10. So the voltage across the inductor is, now we are having the voltage of 200 volt. Now this is the region that series resonance circuit is called the voltage magnification circuit, because your input voltage is 10 volt but the voltage across the inductor is 200 volt. So this is called voltage magnification or voltage amplifier. It is voltage amplifier. ठीक है यहाँ तक. So this voltage magnification or voltage amplifier is not desired in electrical circuit, but it is desired in electronic circuit. So we will see the next question. So start करते हैं अपना next question, देखते हैं next question क्या है. तो देखते हैं next numerical on the resonance. So our next numerical is, oh shit. So the current in the circuit shown in figure is, पहला ऑप्शन है हमारा 5 एम्पियर, नेक्स्ट हमारा ऑप्शन है 10 एम्पियर, सी ऑप्शन जो है हमारा 15 एम्पियर है, और डी ऑप्शन जो है 25 एम्पियर. ठीक है, डायग्राम देख लेते हैं क्या है. सो डायग्राम है 100 वोल्ट 50 हर्ट्ज, और फिर है 20 ओम, और ये रही करंट आपकी, इंडक्टर लगा हुआ है, एंड कैपेसिटर, और इंडक्टर जो लगा हुआ है इट इज ऑफ 200 वोल्ट एंड कैपेसिटर इज ऑफ 200 volt. Okay, so let's find your answer of this question. Okay, so in the circuit shown in figure the current is, okay, so let's find the current value. Now if you see from the diagram, it is VL and it is your VC, and VL is 200 volt and VC is also 200 volt. Okay, and they are also in opposite phase. If you see your phasor diagram of the resonance, and it is VR and it is your VL and it is your VC, they are out of phase. That means their sum is, they are out of phase. That means there's some difference is zero. So when the voltage across the inductor and voltage across the capacitor are zero, that means equal. When the voltage across the inductor and the voltage across the capacitor are equal, that means there is a condition of resonance. So at the resonance the current through the circuit is B by R, or we can say V by Z, and Z is what? R, because at the circuit resonance circuit the Z is equals to R. So how much is your supply voltage? It is 100. And how much is your resistance? 20. So it is 5 ampere. Okay, so at resonance your current is 5 ampere and it is in the series resonance circuit, so its option is 5 ampere. Okay, next question देखते हैं क्या होगा. Let's see the next question. So our next question is, our next question for the resonance is, two magnetically uncoupled inductive coil. Two magnetically uncoupled inductive coils have quality factor Q1 and Q2. Okay, at the chosen operating frequency, okay, their respective respective resistances are R1 and R2. R1 and R2. Okay. When they are connected in series, when they are connected in series, their effective quality factor at the same operating frequency is हमारा नेक्स्ट ऑप्शन है, सॉरी हमारे ऑप्शंस हैं। ऑप्शन है हमारा पहला Q1 R1, Q2 R2, ठीक है। अगले ऑप्शन की अगर हम बात करें तो बी ऑप्शन जो है हमारा है Q1 डिवाइड बाई R1 प्लस Q2 डिवाइड बाई R2। अगले ऑप्शन की अगर हम बात करें तो देखें क्या होगा, Q1 R1 प्लस Q2 R2 अपॉन R1 प्लस R2, ये हमारा सी ऑप्शन है। अगले ऑप्शन की अगर हम बात करें तो हमारा नेक्स्ट ऑप्शन डी ऑप्शन है, वो है Q1 R2 प्लस Q2 R1। So these are the option for this particular question. Now see, there are two magnetically uncoupled coils. So first word we have to emphasize that uncoupled, because in magnetic circuit we have the magnetic coupled coil. What is the meaning of magnetically coupled coil? That means they are like that. If there is a mutual inductance is given, then it is mutually coupled. It is mutually coupled. Okay. But in the question they have two magnetically inductive coils, and that means they are like that. First coil number 1, whose inductance is L1 and resistance is R1. Similarly, we have the L2 and it is R2. Okay. And this coil is having quality factor Q1, and this coil is having quality factor Q2. Okay. When they are connected in series, the effective quality factor at the same operating frequency is now. So अगर इन दोनों coils को हम series में connect कर लेते हैं तो देखिए क्या होगा, like that. It is R1, R2, it is L1 and L2. This is a series connection of coil. So we have to take this part also, because this is our question theory, and I have just tell you what is the meaning of mutually coupled coil. Now, when they are connected in series, what is the quality factor? First, we should know what is the quality factor. Quality factor is omega L by R. Okay. So for this quality factor of this coil is Q1 is omega L1 R1. Sorry, it is omega L1 upon R1 for this. Similarly, for the coil 2, it is Q2 equals to omega L2 upon R2. Okay. Now for the series combination, the total quality factor is what? If you are having total inductance as total inductance is what? L equivalent equals to L1 plus L2, then omega L equivalent, okay, upon R equivalent. The quality factor is like that, na? So it is omega L1 plus L2 upon R1 plus R2. Let's see the option. Is there any option like that? I think no option. Okay. So we will see this part here. Now, if you are having omega L1 omega L2 upon R1 plus R2. Is there any option? No, such type of option is not available. Now what we can do for this? If you take this part omega L1 plus omega L2 upon R1 plus R2. Now if we multiply and divide by here R1, here also R1, here R2, and also multiplied by R2. Okay, then this is your quality factor 1 na, clear hai? And similarly this thing, just wait, this is your quality factor. Similarly this is your quality factor 2. So if you are having Q1 R1 plus Q2 R2 upon R1 plus R2, let's see the question option. Q1 R1 plus Q2 R2 R1 plus R2. Yes, we have the option. So option number C is correct. होपफुली ये समझ में आ गया होगा और एक बेहतर बढ़िया न्यूमेरिकल है on the quality factor. Okay, so let's take the next numerical. So our next numerical for the resonance is, I hope so you are the next देखते हैं क्या numerical है. Now next numerical for the resonance is, at resonance the given parallel circuit constituted it is by an iron cored coil, and a capacitor behaves like. Now your option are a short circuit, then next option जो है हमारा a open circuit and open circuit. Then we have the next option, a pure resistor of value R. ठीक है यहाँ तक. And the last option is, the D option is a pure resistor of value much higher than R. Okay, so let's see that. So at resonance, first thing it is in resonance, because we have to keep in mind our topic is resonance. Okay, so if we draw the diagram, it is what iron cored coil, okay, in parallel with a capacitor. Okay, now if you see, this is a practical tank circuit that we have studied. Practical tank circuit. It is a practical tank circuit. Okay, whose dynamic impedance, if you studied your notes or you just seen your lectures, it is L upon RC. Okay, L upon RC. Then this ZD is a pure resistor. Okay, it is a pure resistor because It is obtained when the imaginary part of the admittance is 0. When the imaginary part of the admittance is 0, your admittance is purely resistive. That means your impedance is positive. But this value is very greater than R. That is the pure resistor, only pure resistor. So according to the question, our answer should be, this is short circuit, wrong. Open circuit, wrong. Pure resistor value of, no, it is greater than R, this R. So a pure resistor value much higher than R. So it should be the answer of D. Okay. So these are the question about the resonance. Now हमने जो अगर AC में पढ़ा है तो उसको अगर summarize करें, first we studied the RMS and average concept and numerical on that. After that we studied the phasor concept, property of phasor, definition of phasor, and numerical on that. After that we studied purely resistive, purely inductive and purely capacitive circuit, and then we take the series and parallel combination of electrical elements like RL series, RC series, RLC series, then RL parallel, RC parallel, RLC parallel, and we have covered number of numerical on that topic also. Then after that the combination of elements, we study the types of power, the active power, reactive power, apparent or complex power, what is their physical meaning, what is their unit, what is their formula. We have studied all the things, and numerical also. After that we take the power factor improvement, definition of the power factor improvement, universal definition, circuit wise definition, range, and the method of improvement power factor. Everything we have studied about the power factor, that is in our syllabus. Then the last topic of AC circuit was resonance. In resonance, first we define the resonance, what is the resonance meaning. Then we divide or classified our resonance into parallel or series, and we have almost covered 21 points with respect to resonance. And lastly we see the dynamic impedance, and that the question is also based on the dynamic impedance. So this is about your steady state single phase analysis. Now in the next lecture we will study our three-phase circuits. So let's start the three-phase circuit. Okay, so up to here we have covered the AC part.